Okay, we'll go ahead and get started. Well, welcome. Thank you for joining us today. You're at the session USGS Science for the 21st Century. This is very much going to be a conversation and discussion session. So hopefully you're prepared to share and talk a little bit with us today. First, just want to acknowledge that many of our colleagues out west are likely on the front lines battling wildfires and sending our best to them. We will be talking about related issues today and hope for a good discussion. The purpose of this conversation really is to really learn and share about new research efforts and developing science initiatives at USGS and really engage in an interactive discussion to help shape the future direction of these initiatives. Understanding our engagements with agencies about management challenges, our response to those in potential science activities, getting some additional input before then launching into calls for proposals or developing projects, and then again, continuing that process of engagement and input. So note that the agenda that you have received online is slightly different than the agenda that we have. We made a couple swaps. But we'll be talking about everything from fire to fish and wildlife disease and invasive species to climate science, and then having time at the end for a facilitated discussion for anything else that we didn't touch throughout the day. So the format is a lightning talk. So each of these topics is going to be touched with a 5-minute, here's where we're moving on this topic, and then some focal questions. And really the idea is to have a conversation. So 5 minutes of a lightning talk and then a focal conversation with 10 minutes dedicated to a particular question. And we're really encouraging conversation and dialogue in this process. I know that it can be awkward on Zoom, but we're doing our best and hope that you sort of share and try to be as comfortable as you can in this process. So a little bit about who we are. So we will be doing our introductions as we come for our session. So to not take so much time that we hope to have for conversation. But great lineup of folks, again, from wildlife disease, invasives, Gayla, Wesley, in genetics and genomics, Margaret, fish and wildlife, David Hu, and amphibians, Mike Adams, Paul Stebline on fire and landscapes, and then myself on climate. And then we'll turn it over to Anne in a moment here, Anne Kinsinger, Associate Director for the Ecosystems Mission Area for USGS. But before we do that, just wanted to try this out a little bit and get folks comfortable with the idea of conversation, discussion, participation. And feel free to share your video when you come on to talk. But we have a link in the chat. The link in the chat is not to supplant or take over for the conversation, but if for some reason you can't unmute and you want to share, this is another way to share that information. It also gives us a way to, instead of relying all the information being embedded in the Zoom chat, we can take all the information that is in this online form and then use it and share with our program managers and staff. So don't go through and complete the whole form now. We'll go through it as part of the conversation. So again, you'll have the lightning talk to sort of spark the conversation and discussion. It's available if you have to leave early, so for another week or so. So please continue to save that link if you didn't complete the survey today. We'll see where we are. I don't think we'll have to necessarily raise hands. We have a relatively small group today, and so hopefully folks can just sort of share as they feel comfortable by unmuting and answering the question. So with that, let's just try it for a moment here. What was the location of your worst field experience? Anyone want to share? You don't have to go into details on the field experience, but what was the location of the worst field experience? Parking lot's good. What city and state or country? Jessica. And feel free to unmute in Gainesville. Who's going to be the brave person to unmute?
I can give you a best and a worst. This is John Thompson.
Let's hear it.
It was the same place. It was in Yucatan, Mexico. And I did my doctoral work there, and it was incredibly beautiful, but also incredibly frustrating just to get set up. It took 3 to 4 days to buy a single sheet of plywood. Even though the plywood was right there. Yeah. An interesting time.
Good times.
This is Sharissa Morris from the U.S. Fish and Wildlife Service. It actually took me a little while to think about a field experience I didn't enjoy, but it was doing stream work in Maryland because all of the understory is greenbrier and multiflora rose. And prior to that, I had been working in Appalachia where the streams were gorgeous and covered in mountain laurel and rhododendron and just an absolute delight. So it broke my heart to have to do Maryland stream work.
Great, thank you. And Rick, the poison oak forest in coastal Northern California. Well, great. And it doesn't look like anyone went into the, okay, some folks are going in the forms. Even if you also shared, if you can go in forms and start, because we ask for your name and affiliation, and then again, we'll ask for additional feedback on particular questions if you don't mind. So really appreciate that. Any questions or concerns about the forms or format? And I'll just say I almost lost a rental car to the Gulf of Mexico to high tide on Matagorda Island. That was my field experience. That was the worst. Okay, next up is our Associate Director, Ann Kinzinger, from the Ecosystems Mission Area. In this role, she is responsible for USGS research and monitoring on freshwater, terrestrial, and marine ecosystems and the human and fish and wildlife communities they support. And I'll just advance as you.
What's that?
Just let me know when you want me to advance.
Yeah. And thank you all for coming. We're really excited by a chance to share our science with you and to make new connections, renew existing connections, and in particular hear your emerging research priorities and see where we can identify and help with future science initiatives and studies that'll meet your needs. Next slide. So I wanted to share a couple things with you before I start talking about some of our science areas. The Earth Map initiative in USGS is designed to help us bring together all of the capabilities we have across all of our different mission areas in USGS to do a better job of creating kind of advanced technologies and decision support tools for our partners. And so what that means is that, we're trying to link all the stages of research, starting with the basic research, moving into the collection and integration of data, looking at models and improving our models and coupling models, all the way to the endpoint for our partners, which is the development of high-level visualization, scenario assessments, and forecasting tools and those sorts of things that will help with decision making. So the strong focus on the end user engagement, really want to focus also on developing new capacities that we might need in order to do this better. So we're conducting a capacity assessment. We're reaching out to our stakeholders, getting our program requirements and so on. And we have kicked off a couple pilot projects with the intent of bringing together information on the basic geology and the water, the hydrology and the water modeling that we have going on in places, all the way to relating all of those kind of abiotic factors to biological outcomes for fish and wildlife. And so one of the places we've been working is in the Delaware River Basin, focused on understanding coastal and estuarine processes, as well as just starting in the Colorado River Basin, where we're looking at drought impacts on the biophysical processes and looking at actionable information before, during, and after fires. So a new initiative with USGS based on capacity we've been developing for well over 100 years, and really trying to bring it together with a laser-like focus on our partners. The other thing I wanted to mention that just happened on September 4th was that we have received approval at USGS to merge some of our mission areas and go from 7 mission areas to 5 mission areas. And what that means for the ecosystem mission area is that the climate research and development and the climate adaptation science centers and the environmental health programs are being merged into the ecosystem mission area. And we're quite delighted to have them. We think it'll be a great opportunity for us to do the integration I was just talking about, start to do that across program areas and link up some of the information on stressors, whether it be climate or contaminants or toxic substances, connect that to the end out points of fish and wildlife and their habitats. So very excited by that new change, and we'll be implementing at what we hope is lightning speed to get that all together. And so you'll be seeing a lot more of that later. Next slide, please. Just quickly wanted to show you the ecosystems locations across the country. We have people in all states. We're doing research at 16 science centers, 44 cooperative research units, and 8 climate adaptation centers, with the goal of setting up a new climate adaptation center in the upper Midwest. So we're out on the landscape. I hope that those of you who are on the call have had a chance to work with our folks in the field and co-produce the science that you need to make your management decisions. Next slide, please. So just quickly, these are some of our priority science areas. You'll see them woven throughout the presentations that we have today. But these align with where we want to be in terms of 21st century science, and as well as lining up with the Department of Interior as a whole and our sister bureaus. So first one, assuring sustainable fish and wildlife populations. We know that outdoor recreation and tourism contribute a tremendous amount to the US GDP. And what we're focused on is providing the information needed for decisions that can sustain healthy fish and wildlife populations. Things like sustainable harvest, cost-efficient fish and wildlife monitoring strategies, and mitigating natural and human-caused threats to species. And a particular focus for us is to bring our science to the table to inform hard decisions for at-risk species. And this is really focused at the Endangered Species Act. We've got federal protections for more than 1,600 at-risk plant and animal species across the US and its territories. And what we try to do is fulfill critical information needs and bridge science with management across the country for those species that our sister bureaus need to manage and make decisions about. So it'll be things like science understand species threats and survival, helping managers develop strategies to minimize threats, and working very closely with state partners on the state wildlife action plans. You'll hear a little bit more about this today, but help battle biological threats to human is really focused on invasive species, pathogens, and environmental contaminants that affect every state in the country. And we provide information for everything from public safety, public health, and property to science to mitigate biological threats and preserve environmental health for fish and wildlife species. An area we haven't talked about too much, but it was a growing part of our portfolio, is to assist you in managing risks and responding to extreme events. And that's things like weather and climate disasters. Don't need too many reminders of that at the moment. with hurricanes and fires and coastal hazards. But what we try to do is inform citizens and managers about the potential risk of these hazards and what kinds of risks they pose to natural systems in the environment to improve preparation and response activities, and of course, protect the health of the public. We provide science to preserve and restore iconic landscapes. We have a very large research program in the Great Lakes ecosystem, which is really providing a decision-making backbone for a $6 billion regional economy focused on commercial fisheries. We have science capacity in a large number of critical ecosystem areas, things like the Arctic, coastal zones, wetlands, forests, deserts, and are working to be able to characterize response to both natural events and changing land management practices like water management, fire control, agriculture, and the like. And then finally, we, particularly with the addition of the Climate Adaptation Science Centers and Climate R&D, we support adaptation to climate impacts and address the impacts from climate and land use change across the country. And we know climate and land use change is rapidly altering ecosystems. The question is, what can we do to help mitigate and reduce the risks associated with decision-making in that environment? So we do work with natural and cultural resource managers to gather this information and then build the types of tools that I was talking about earlier to help fish and wildlife and their habitats to adapt to the impacts of climate change. Next slide, if you would. So I wanted to dwell a little bit on the cooperative research units because they're quite of interest to AFWA and are really the keystone to our relationship with our state partners. Got a couple highlights. We have a new cooperative research unit chief starting on September 27th, and he will be quite familiar to many, if not most of you on the call. He is Jonathan Maudsley, who is the science advisor to AFWA right now. And so we're really looking forward to having him on board very soon. We've got about 39 science vacancies at the start of this fiscal year, but we were really heartened because we got a 5.6 million budget increase in this fiscal year, and we're working hard to fill those vacancies. We've actually got hiring waivers, which are basically our permission slips to hire for 35 of 39 vacancies. And so we've got a lot of progress that we'll be able to report to you in the future. And all the while still conducting more than 640 active research projects and one really important aspect of co-op units, 550 graduate students and postdocs who we're delighted to be training for kind of the next generation of natural resource professionals. Next slide. That's the end of my presentation. I tried to go quickly because I know the conversations we're going to have is the most important part of this meeting. So thank you very much. I'm really looking forward to hearing the rest of the meeting. I'll sign off unless there are any questions.
Thank you, Anne. Okay, next up is Paul Stepline from the Wildland. He's the Wildland Fire Science Coordinator.
Thank you. Can you hear me okay and see me okay? Next slide. It's a real pleasure to be here speaking with you today. I grew up classically in wildlife biology and 22 years in the refuge system, and now I'm in fire, and there's been a little bit of a bridge needed between fire and wildlife management, fish and wildlife management, land management. So I'm pleased to be here. I am keenly interested in what your management issues are related to wildland fire, and I'll get back to that near the end of the presentation. Next slide. So we're all familiar from the headlines what's taking place right now with fires this year, and there's been many notable years in the last decade. It's important to note that despite efforts to suppress fires and manage to reduce fire risk, our ecosystems in the United States and around the world evolved with fire as a key driver, as well as the patterns we see in fire represent how we've managed the land over the last couple hundred years. Let's see, there's one of the, there we go. Fire is also a critical land management tool, whether or not to control invasive species, some are vulnerable to fire, or to bring about fire-adapted species, such as loblolly pine that depends upon fire to open the cones, or Kirtland's warbler that depend upon jack pine for habitat. Yet the fires that we see today, the kinds of fire patterns are having big impacts. And so approximately $5 billion a year for fire suppression. But when you round up all the different kinds of impacts to the economies, to health and safety and assets, and the land use, recreation, the wildlife hunting, and other uses, it totals more than 80 billion a year, maybe as high as 200 billion. And there's many factors that are affecting it. So climate change is one that's talked about quite a bit. Build out into the wildlands. Human ignitions are responsible for about 85% of fire starts. Insect and disease outbreaks. Across the deserts, the high desert and the southwestern deserts, invasive species is flipped upside down the historic fire regimes in those areas, where once fire occurred maybe every 500 years, it is now 8 to 15 years between fires. But it creates uncertainty, and it makes it very challenging for land managers to try and address these issues. Next slide. Land fire is one of the big data products that we produce. It's co-produced with the Forest Service. It's a very rich assortment of data layers. It's been out there for 10, almost 15 years. But vegetation, fuels, fire regimes, or the historic patterns of fire, departure from historical conditions. So what should be the habitat? What should it look like if it was managed according to fire return intervals, terrain characteristics, and then disturbance to the vegetation? It's used for many different things. The map on the right is, it shows vegetation and fuels, and then fire perimeters. That's used for both fire and land management planning. Land fire, like I said, it's been around for a lot of years, working on improving the speed with which vegetation and data are updated, including such things now as these fire-adapted invasive species like cheatgrass, to incorporate that in, looking at how to update it with fuel treatments to the prescribed burning or thinning that's done. And then finally, the little picture in the center is from one of our projects down in the southern border at Buenos Aires Refuge. We are looking at how to move to the next generation of land fire. So where we're using physics-derived fire behavior models, using three-dimensional vegetation to fire the model, if you will, and with local weather, micro weather characteristics. And to be able, but we need the data to be able to do that. There's advances being made, but there's still time ahead that will take to accomplish that. Next slide, please. Landsat is a key source of the data that goes into land fire and so many other applications. USGS is the host and manages the Landsat program. It is free satellite imagery that's available. A pretty constant cycle of planning the next mission, planning the next satellite that will be launched that is in the Landsat family. And it's quite a historic record with for similar types of data going back to 1984. Probably a lot of you are familiar with it. Includes multispectral, but also infrared bands. Some of the current discussion for future Landsat satellites and source data is potentially hyperspectral bands, higher resolution, both spatial, so reducing the pixel size, as well as temporal, greater cycle of time. And then considering other technologies such as LiDAR, which was used to create that three-dimensional vegetation characteristic, which is on the last figure. There's also many other commercial and government types of data that's available. A lot of it is served through EROS, which is our Earth Resource Observation Science Center in Sioux Falls, South Dakota. Next slide. Burn severity is the last data type I'll talk about. This is a set of data going back to 1984, and it's been caught up to 2018. They'll have 19 soon, but it's used by many people to look at the impacts that fire has. So burn severity is the extent to which vegetation is consumed in the organic matter, and then the impacts to the physical and chemical characteristics of the soil. So it's used for all the debris flow modeling to look at the potential for rechannelizing and landslides that take place, hydrologic modeling for both water flow and water quality, and then for bearer plans, burn area emergency response plans for reestablishing vegetation. So this is a broad data set that's available. Next slide. It's my last slide. So I can only touch about a small tip of what we do in fire science. We have 150 plus scientists. We are just coming out with our first strategic plan on fire science. I think next week it will be released, but we have an aggressive science strategy that integrates new technology, new capabilities, new scientific principles. We also work very closely with stakeholders using a co-production approach and work through the whole life cycle of science with the stakeholders. Communication is a big feature, looking at what science and capabilities we have, how to reach out to them, and make sure that we can translate it in a way that's meaningful to the public. And finally, seeking organizational excellence within USGS as well as our partners. So this is my last slide. There's my contact information. We have a tremendous amount on our web, and I'd like to hear what either your questions or where you need help on fire science. Thank you.
So feel free to unmute yourselves and share. So Paul, I see someone in the forums talked about resiliency and restoration on the landscape and at-risk species fronts with regard to fire as a emerging need.
Yes, restoration of resilience to fire is one of the 3 goals of the cohesive wildland fire management strategy. And just to translate that a little bit, one of the things, for instance, ponderosa pine is evolved with a pretty quick return interval of fire. And because of the accumulation of fuel, when it does go up now, there's crown fires with very damaging impacts. And so if we can thin those and use prescribed fire to return fire to a normal fire cycle, it increases the chance of keeping ponderosa pine longer with climate change taking place, as well as reducing the impacts to society and ecosystems. Other questions, comments?
Yeah, this is Doug Bremeyer in Wyoming. Can you hear me okay?
I sure can. Thanks, Doug.
Yeah, so in Wyoming, we're becoming really concerned about the expansion of cheatgrass and mapping capabilities. We've got some initiatives that our agency is moving forward with to do some mapping, but I'm sure the USGS has some expertise in that field where we can start to at least document where we have it. We're trying to develop a tool now where we identify some of the habitats where we might have the best success at moving forward with treating it. But our concern is getting to the point where you'd have these wildland fires that propagate the expansion of cheatgrass, and it just makes it really difficult to treat it.
Yeah, that's great question, great concern. Across the sagebrush steppe, cheatgrass has been extraordinarily challenging. And like I said, flipped upside down, the whole fire return in the sagebrush steppe. We do have a couple of scientists that are doing near real-time fire mapping of cheatgrass, and we'll have to double check to make sure the extent of that mapping covers Wyoming. I think it does, as well as the actionable fire science plan for the integrated rangeland fire management strategy. It's always tough to keep track of, but a great deal of projects and studies looking at how to control cheatgrass. There is no silver bullet, but there is a lot of recommendations and tools to look at how vulnerable a site is to incursion by cheatgrass, as well as what to do after a fire goes through where cheatgrass occurs. And we can glad to get you that information.
That sounds good, thanks. And if you have a contact for who's working close to Wyoming, we can have some of our folks reach out to them as well. Appreciate it.
Excellent, thank you.
Anyone else want to share?
Well, people are, please raise your hands or speak up or text, whatever, but we have a lot of resources on this site, usgs.gov/fire, including a 12-year compendium of all of the science publications and products with links to each of the papers. We have, we're posting all the current publications as they come out, as well as links to our centers and data products that are available online as well. One other thing, I know there's invasive species coming up, as well as climate adaptation. The Climate Adaptation Science Centers this year, because it is such a priority, and I interviewed 40 different organizations on what their priority science needs were. They were fire primarily, so this is important to hear from Fish and Wildlife, but the most common response was, what is the impact of climate on fire behavior, fire effects, and what are the management alternatives? And so that suite of things came out very strongly in the work we did in developing this plan. And the Climate Adaptation Science Centers are doing a review of climate fire interactions and trying to pull existing knowledge together on those questions that came out as important to our stakeholders. Thank you.
Thanks, Paul. And again, we'll still be around, so Paul will still be around. But we'll move on to the next lightning talk, and again, sort of encouraging conversation discussion like we just had. So our next speakers are David Hu, Fisheries Program Manager, and Michael Adams from the Amphibian Research and Monitoring Initiative.
Hello all, and thanks for making time and energy for us today. With my colleague and friend, Mike Adams, today we're hoping to explore the theme of fish and wildlife considerations, in particular related to water availability and use decisions. A little bit more on our thinking over here is the concept of balancing water resources, water decisions, and species biology and habitat needs is nothing new. From stream flows to temperatures to water diversion to water timing, groundwater, spring systems, all those influence in turn soil moistures, wetlands, floodplain activations, in-stream flows. And we depend on all that to meet our agricultural, our municipal, our refuge, and hydropower management needs. All of that while trying to manage some of the major issues with pollution, invasive species, nutrient loading, algal blooms, drought, et cetera, all while trying to manage for the base ecological needs of fish, wildlife, invertebrates, plants, and some very delicate and intricate food webs and some very special critters out there. So how's that for a big gulp? Here at GS, we definitely perceive these changes. And next slide, please. We definitely perceive these changes to the resource management realm here. there's a lot of challenges and a lot of new needs out there. And we're recognizing how these issues and decisions are really becoming more and more complex. They're becoming much more severe in terms of the direct impacts of these decisions, and as well as the cascading implications to these decisions. And oh boy, they're sure becoming more controversial, political, and even physically dangerous social conflicts out there. It's some crazy times and some crazy stuff going on out there. Next slide, please. Here at the USGS, not just in the ecosystems mission area, but also in our water mission area, we've been working on these questions in many different ways, in many different flavors, and in many different programs, and in many different science centers, as well as in our mission areas. However, we do envision that we have a role here, and that we do envision that we could increase our contributions to help the managers out on this. In particular, we recognize that there's a ton of USGS information out there. From the data to the research to very complex and advanced innovative tools, not just in the biological, but also in the physical water realms. The information out there is very complex and it's diverse, and it's being conducted, as I mentioned, through many different science centers in different areas. And we recognize that these may not be well integrated into a form that is the most accessible and usable for the managers here. Next slide, please. So today, what we're hoping to do, as well as in the future, we're hoping to explore and hear more from you. We're really hoping to gather some new insights and some nuggets for us to take and explore and see if we can make these USGS products more usable and more meaningful for you. Here's our interest up front. We would definitely want to work to refine and develop some new tools, stuff that we feel would help optimize conflicting objectives and some of those really challenging and tough decisions. We also want to create more utility and application from the outputs of our tools that we currently have, and different ways to package that, to reframe that. Definitely open to any ideas. We also are looking to model and predict the consequences of different scenarios. This is our bread and butter, definitely stuff that gets us really excited. But here we're talking about the context of ecological flows. Eco-drought would be another way to describe this, or eco-hydrology is another way. We really would like to identify, we want to model, we want to predict these consequences of these decisions. This is a tough task that you all are faced, that we all are faced with in terms of making these decisions. And it's a new world out there. We want to try and help. We want to also apply our climate change models and different scenarios and tie that specifically, at least in my program area, towards the species biology and species needs. Again, we really appreciate your time and energy, and we really are excited to hear more from you. My friend Mike Adams will describe a little bit more about what we're looking and hopefully facilitate the conversation. And Mike, passing it to you.
All right, thanks, Dave. Next slide, please. So as Dave says, we really just want to hear from you. I'm going to talk for just a second so you can think about this a little bit, but really part of what's going on here is we're trying to think ahead as to what might be possible. You have all of these different sources of information in USGS that are relevant to decisions with water and with fish and wildlife and the intersect of those things. It's possible to envision some really kind of fancy, sophisticated tools, but we want to make sure that whatever we do is well grounded in user needs. Next slide, please. And so we're really hoping to hear from you. You know, the range of things that we could be thinking about in terms of tools is vast. And you think about things like just site level management decisions. I have a slide here with a beaver dam analog. Beaver, interesting because they're managed as a pest, they're managed as a tool, and they're sometimes simulated, as in this slide. But there's all kinds of things, right, that affect, it might be a site level decision that affects water and has broader implications for water. And as water becomes more scarce and contentious, what we think we see is that there's more and more of a need that to consider, I guess, other consequences of these sorts of local decisions that might be targeted at a specific species. Next slide. And then at the other end of the spectrum, in terms of just scale and complexity, would be these regulated basins, which are really all over the place. Lots of conflicting users, lots of different implications of these decisions, and just the need to try and understand the implications of really, what's going on with every drop of water in these systems eventually. So next slide. And so again, we'd really just like to hear from you about anything that you're doing with water, decisions involving water, decisions that are affected by information about water, where the water is, trying to balance different objectives, conflicting objectives, anything along those lines helps us understand how we can be relevant and where to put our efforts in terms of the sort of next generation of tools and capabilities that hopefully will be useful to you. So I'm going to be quiet, see if there's any comments or really just anything you'd like to share about decisions with water.
So folks, please unmute and chime in.
Hi there, this is Cindy Leffler in Texas with Texas Parks and Wildlife Department, and just want to say, thank you for this. Very interesting to think about possibilities going forward. One area that I'm not sure that we'll talk about a lot today, but I just want to give a plug, if you will, for just how invaluable water data that we have now are for these decisions, and thinking about maintaining existing data networks, and if that's something that we'll have a chance to touch on, or if you're really thinking more about, what are our needs going forward. Just emphasize the importance of just maintaining basic water data can't be overstated.
Yeah, is there any sort of improvement to that you can envision? I don't think that the existing network is under any threat.
Well, I'm thinking about, here in Texas, as basic as stream flow gauges, that cooperative gauges, trying to ensure that the funding is there from year to year. We have one particular gauge I'm thinking about right now, where we have at-risk species, lots of different users, thinking about, what's going on there. It's pretty basic stuff, but just thinking about, it's great that we're talking about eco-hydrology, eco-flows, eco-drought. We're doing some of those things, and we couldn't do it without the basic water data that we have in place now.
Now, this is just chiming in quickly. I completely hear you, and we actually had a discussion before this meeting about how critical that data is to any discussions we have about water use and availability. The stream gauge network is pretty safe and sound from a national funding perspective, but as you may have experienced, it sounded like you may have, many of these are cost shared and not fully federally funded, and we do sometimes run into difficulties as the states might experience difficulties. But I would definitely encourage you to get in touch with one of us if that happens, and we can help you troubleshoot. The other thing I wanted to mention is that the water mission area is actually trying to move forward with an even greater degree of long-term data networks. They've got a plan in the works called the Next Generation Water Observing System, which is built on the backbone of the stream gauges, but is also trying to fill in the gaps in those stream gauge information through remote sensing and better modeling and those sorts of things. And I mentioned early on that we're teaming up in the Colorado River Basin, USGS, but a big component of that will be working on their next generation, NGWAS they call it, in the Colorado River Basin to ground test a lot of the new measurements and observations and models. So I think we're on strong footing there and moving to a position where we can actually offer more and not less in terms of the long-term data.
Yeah, thanks, Ann, and thanks for the comment. I've definitely learned in my career that it's sometimes the simple things that are the most useful. So we want to maintain that, and hopefully we'll be improving on that. And there's a lot of discussion around moving beyond just sort of how much water is moving through the system, but you know, where is that water exactly in the system, and how is that affecting fish and wildlife along the way?
Tim, did you want to share?
Yeah, I just wanted to, Tim McCoy from the Nebraska Game and Parks Commission. I think, thanks a lot for you guys' work on the water area of the mission, because it is really critical, and the challenges of dealing with efforts to further manage limited water supplies are challenging, and they're going to continue to be challenging. And having some consistent data that is well respected, and that can help impede some of the arguments about which type of water it is and what the basic uses are. And of course, all of us in states are also tied by whatever the vagaries are of our state water laws, which can also be kind of challenging. But no, I appreciate it, and yeah, the support for the continuation of the stream gauge network and all of that long, rich history of information is really valuable, I think, for us going forward as we continue to deal with a changing climate that has all sorts of different impacts for us in the state, depending on the times of the year and when things happen, and it seems to be more of a flood or drought situation almost, in terms of not ever having anything that's average or normal, at least in the last few years. So thank you.
Yeah, I'm curious, this is sort of a false dichotomy, but I'm curious if anybody has comments on sort of the relative weighting of needing more information on future conditions for water and for habitats, riparian habitats, wetlands, streams, versus understanding immediate implications of decisions involving water, either in regulated systems or things that modify the landscape and how water moves through the landscape. Again, false dichotomy, we're really working on both of those things, I think, extensively, but just curious if anybody has any comments on the importance of those things.
I will respond to that, because that is one of the biggest challenges we face right now, of trying to sort out, as we continue to see the expected shifts in climate, what it's really going to mean for our aquatic systems. I'm basing this on short-term memory in the last 10 years, but it seems like we're having too much water and not enough water, sometimes in the same year, with the shifts in precipitation and large events. So it's going to be a big challenge. And I also see challenges coming from, at least what we're seeing, what appears to be shifts in flood regimes. I think there's going to be public infrastructure challenges that are going to be pretty pressing if this continues, whether we've had a couple of 5 years that are just an anomaly, but if this is our new future, it's going to be pretty significant for way beyond fish and wildlife.
I also appreciate the comment from Chris Estes here, this thing about linking. We have all these sources of information, but it's not well linked, it's not well modeled or well integrated right now. And that is exactly the sort of thing that we're trying to think about, how to sort of get all of this information on where water is in the different places in the system, even going as far as like soil moisture, in the uplands. Trying to understand all of that and do a better job of integrating that information, as well as modeling and predicting implications for fish and wildlife in those systems under future scenarios and under different current management scenarios. We're probably running out of time here, but happy to hear any additional comments on that, or you can always add to this form that's available if you think of things later. All of that helps us kind of just stay well grounded in utility for whatever it is that we do going forward.
Thank you both. Yeah, so a good reminder. So the forum is open. You can add comments there. You can add them in the chat as well. We are going to be around at the end of the session too for discussion and conversation, and then you can always follow up with us later too. Okay, so next up, it'll be me. My name is Olivia Ledee. I'm the acting director for the Midwest Climate Adaptation Science Center. And I'm going to be highlighting the work of the Climate Adaptation Science Center and USGS in climate adaptation science. So one of the questions folks will have is sort of, what do I mean by adaptation science? Because often folks think about implementation, so actually doing the shovel work of implementing climate adaptation, but we're talking about the science. So both identifying potential management options as well as evaluating those management strategies to see whether or not they reduce vulnerability or increase our conservation success for the management of fish and wildlife. We are always interested in manager engagement. Often these are local scale efforts. Often those things that you might do to manage populations or their habitats don't always translate to regional or national scales, and we are looking for evidence-based work. So I think it's Tim in Nebraska was just talking about sort of extreme precipitation, right? We know that's an issue in the Midwest region, for example. Right, so that's your physical science of climate change, and then there's the work of translating that into vulnerability. So looking at land use and climate, and how that affects population trends, for example, for black terns. But then we know through research that if we put nesting platforms out, that even under heavy rainfall events, we can increase nest success. So that's where you have a climate trend, you have known vulnerability, and then you have both the plasticity in the organism as well as the management knowledge to that this intervention will be successful. We need this work to be done on a much greater scale. So we just completed a review of best practices recommendations for adaptation, and we continue to recommend to resource managers increase the size and connectivity of protected areas and sort of promote a wildlife friendly matrix, things that are often outside of the purview of your typical area wildlife manager, for example. And we are interested, if we are going to make gains in conservation, of pushing the science forward to not just best practices and the precautionary principle, but to what are those interventions that we know will yield better conservation outcomes. So to just give you a flavor of that, I'm just going to share 3 projects that we have going in our program across the country. So one is related to fire management. So managing habitats, sort of like this beautiful pine forest, is increasingly challenged, be it invasive species or altered weather conditions. And in the Southeast, they are having challenges with having the number of suitable burn days. So either when you can burn is different, so the timing of the season because it's too wet, or the number of days where you can get a good sufficient burn to meet your habitat goals, right? So there's risk associated with action, be it wildfire, for example, as well as inaction where you're not going to meeting your habitat and your ecosystem function goals. So this project, which is being led by Adam Tarando, who's a research ecologist with our Southeast Climate Adaptation Science Center, is looking at historical climate observations and models to look at emerging local trends and use that to create an early warning system that can look at short-term and long-term risk on those fire decisions. So putting that information, additional risk analysis information in the hands of resource managers to determine sort of more suitable burn conditions. Another project that's happening here in the Midwest, this is in partnership with Minnesota DNR, for example, is about a novel approach to disease management. So moose have been in decline in Minnesota for over a decade, and sort of the remaining population has declined by 60%. And in their moose management plan, Minnesota DNR identified foraging and thermal habitats as a priority, research priority. So this project led by Dion Donner out of US Forest Service is looking at those conditions that are most suitable for deer versus moose, can we increase segregation of these two species on the landscape, providing good thermal cover for moose, and reduce the number of deer-moose interactions so that we reduce transmission of brain worm. And there's some recent research that shows this is really promising. And so they will identify spatially explicit subcultural treatments to reduce those transmissions, to reduce contact, and create thermal microrefugia. And then the last example is about seasonal population management. So looking at changing snow winter conditions and how that affects both game and non-game species on the landscape. So we know our snow conditions are changing and our organisms have been adapted to these. And so now as we have more rain on snow events, it affects forage access, it affects, energy use, it affects the ability to thermoregulate, and a concern for these organisms. And so the idea is to have real time, right? So within a season, understanding of winter severity and techniques to identify snow refugia so that you're not responding after a very severe winter. So that the next season with population management, you understand what's going there, and be it you need to provide supplemental food or be more conservative with your season, you have information to do that almost in real time. So that's looking at field measurements, weather stations, and a camera network to get that information. And it will look, again, will provide real-time information on winter conditions for managers to adapt their practices that season rather than the following season. So those were just a few examples of projects. And so have two focal questions for you all. So one, where might there be good examples where you have a need and you know that research could accelerate that evidence-based adaptation for population or land management? So where you know you have a climate driver, you have some long-term data, you have a problem. And then the second question for you to bite on is what opportunities do you see for USGS to provide technical assistance on climate change and adaptation? So two questions, and encourage folks to unmute and chime in. Thoughts, questions, concerns? I know one person was interested in the.
Yeah,
Suzanne.
Olivia, we have David Smith has his hand up, so.
Oh, sure.
Yeah, Olivia, how's it? David Smith calling in from Hawaii.
Hi.
One of our big concerns right now is regarding mosquitoes and endangered forest birds. And it seems like, we've always known that, mosquitoes are held down at a certain elevation due to temperature. And now it seems like with climate change and warming, generally warming climate, that line has gone up perhaps significantly. And so we're really interested in landscape scale mosquito control. If we don't get something like that, we're going to start getting native forest bird extinctions, probably we're estimating up to 4 in the next 5 years. And so it's kind of a dire, all of a sudden, it's like gone from 4,000 feet elevation to 5,000 or more. And so we're losing a lot of habitat that way. I'm just wondering, we work with USGS over here quite a bit, but we're just curious about, what it would take to accelerate a program to work on landscape scale mosquito. And do you have any examples from elsewhere where it's being done?
Yeah, so my colleague Mary Vaughn out in the Pacific Islands is actively interested in this and is pursuing a project now related to this and looking at larval habitat and both sort of detection and management, and could have her follow up with you if that would be helpful. I know it's a focus area, and I know that's a project that I think will be coming online pretty soon here.
Okay, great. Is she out in the islands? Or where's she based?
She's based in Hilo.
Oh, in Hilo? Okay.
The Pacific Islands Ecological Research Center has a whole number of projects. David, you're probably familiar with those. Looking at both the possibilities for controlling mosquitoes, adaptation in the honey creepers. They've got monitoring stations up and down the mountain. They've recently released a malaria watch tool to help sort of look at some of the spread of the plasmodium in the mosquito population. So definitely a bunch of USGS scientists in Hawaii working on that, but it seems dire, so I hear you.
Yeah, it's really accelerated. Just recently, we tried to do a release of Maui parrotbill over on Maui, and they all died in a week because they were at 5,000 feet, and it used to be like common knowledge was, mosquitoes are at 4,000 or held at 4,000. Well, now they're at 5,000 plus, and in such densities as to be able to completely wipe out a project that had been planned for many years. And so all of a sudden we're in a new world where, we got significant new challenges and, species that are probably going to start blinking out if we don't get on it pretty quick.
That's noted. Thank you.
Any other thoughts or comments folks want to share, either sort of opportunities like that or about technical assistance in climate adaptation, climate science?
You're muted, Olivia.
Oh, I was just joking that we're trending in the direction of less conversation, but we want to go the other direction. Yeah. Any other final calls for comments or to share? Okay, we will go to our next set of presenters. So we have Wesley Daniels, Acting Invasive Species Program Manager, Gayla Vasquez-Neves, Biosafety and Biosecurity Specialist, and Margaret Hunter helps with presentation.
Thank you, Olivia. I have the pleasure of going first, and I'm going to talk a little bit about all the great work that's going on in the Biological Threats Program, specifically towards invasive species management. And then Gayla will speak towards the disease side of this. USGS is leading in biosurveillance, including risks prediction and forecasting, early detection, and enhanced situational awareness for biological threats. We're developing new, innovative, actionable tools and data for every stage of invasion in support and collaboration with our partners. For today's presentation, I'll be highlighting some of these biosurveillance tools that predict and forecast. And this is in no way a comprehensive list of all that's going on at USGS because we have a breadth of different programs and projects within the Biological Threats Program. But I'll highlight a few of these actionable tools and data along with discussing the future of biosurveillance at USGS. Slide. Thank you. So the first product is Inhabit. And Inhabit is a tool that's created to connect managers at a national, regional, and local level with species distribution models that can be used for risk assessment. This risk and forecasting tool boasts distribution models for more than 70 plant species, and with more, including animals, being added each year. The maps are of a national coverage at 90-meter resolution and include the ability to toggle between more and less conservative estimates of habitat suitability. Inhabit contains both spatial data maps and non-spatial statistical summaries. Slide. The Non-Indigenous Aquatic Species Database, or NAS database, is the foremost national repository that monitors, records, and analyzes observations of non-native aquatic animals and plants throughout the United States and its territories. Non-Indigenous species can be either foreign or domestic and occur in waters outside of the historic native range through human intervention. Currently, the database tracks greater than 1,300 species and has data dating back to the 1800s. Slide. One of the new tools developed by the NES team is the Screen and Evaluate Invasive and Non-Native Data, or SANE tool. The SANE tool will allow users to upload a biological data set that can be screened for any of the invasive or non-native aquatic species tracked by the NES database. To utilize this resource, users can find automated tool on the NES homepage. They must upload a spreadsheet to the SANE tool, which will rapidly screen the data, and it has the ability to process hundreds of thousands of records in just a few minutes. And then it will provide back to the person a second spreadsheet with all the process data, including some additional information on geologic and geographic connections of their locations from this original spreadsheet. The data that's provided back to the user is a bonus and helps when managers don't have access to GIS technologies. And upon completion from the SANE tool, users will be prompted to share their non-native data with NAS. However, they may do so at their own discretion as it's not required. Slide. Environmental DNA, or eDNA, is a powerful tool that's been used to detect microorganisms for 30+ years and has recently been optimized to detect invasive and imperiled invertebrates and vertebrates species. USGS is a leader in the federal government in development of methods and applications of eDNA, both targeted and community sequencing. Slide. Currently, there are 79 eDNA projects occurring across USGS. A few of the examples include development of a portable eDNA lab in a suitcase for rapid detection of ohio death, which affect mature ohio trees in Hawaii, and for Asian carps that have the potential to spread through the bait trade. eDNA is also being used for early detection of invaders, including the potential spread of zebra mussels into the Columbia Basin. USGS is working with others to look towards automated sampling devices to be integrated on the national network of USGS water gauges, which will stand as sentinels on our streams to alert managers of new aquatic invaders. And finally, we're working to integrate all of our eDNA detection information into the NES database. This will allow eDNA detections to be tracked alongside visual detections within a centralized source. Slide. So where is USGS headed? We have two words, interoperability and synergy among the various projects and programs of USGS. We have a goal to build a centralized biosurveillance platform. We want to engage stakeholders and other DOI partners and develop the capacity and infrastructure and pipelines between our existing projects and programs for new central biosurveillance platform to help can promote risk and forecasting models. This centralized searchable online biosurveillance platform will be a source of actionable intelligence and provide situational awareness for invasive species and wildlife diseases, including endemic, high priority, and emerging diseases and species. Slide. So as we transition between our discussion of invasive species, we're going to go straight into Gayla's work with wildlife disease. But we do pose the question, in your mind, what is your most pressing need for invasive species management? And we're happy to discuss this at the end of Gayla's talk. And this question is also available to you on your forms document.
Thank you, Wes. Can you hear me?
We can hear you.
Okay, hi everybody. My name is Gela Vasquez and I am the Biosafety and Biosecurity Specialist for the Ecosystems Mission Area. So as you know, the wildlife diseases investigated by USGS scientists have been increased in number and diversity since 1990s. In the 70s, the majority of the investigations were focused on wild birds. Today, USGS scientists are investigating diseases impacting coral reefs, snakes, salamanders, bats, deer, elks, and birds. Next slide, please. I want to talk a little bit about FEMA. Why? Because when the president declares a disaster declaration or an emergency declaration, USGS is identified as the lead for wildlife and zoonotic disease surveillance in FEMA's emergency support function number 11. When this emergency declaration is declared, USGS primarily through the National Wildlife Health Center monitors diseases in wildlife populations, predicts the ecological and public health consequences, and provides data for disease management practices. Remember, wildlife diseases are at the interface with not only public health, but also domesticated animals' health. Therefore, aquatic and terrestrial wildlife disease work at USGS includes collaboration with agencies concerned about human health, such as CDC, NIH, DOD, DHS, and USDA. It's very important to say that the National Wildlife Health Center is the only federal high containment facility dedicated to wildlife disease surveillance and research. Next slide, please. The National Wildlife Health Center was established in 1975, and this was the first federal program devoted to address wildlife disease problems, including responding to wildlife die-offs, technical assistance in diagnosis, prevention, and control of diseases, as well as disease research. It's very important to mention that this center now is affiliated to the laboratory of the USDA National Animal Health Laboratory Network, and it is also an affiliate of the World Organization for Animal Health. For over these 40 years, the National Wildlife Health Center has supported DOI by investigating wildlife disease outbreaks. All those historical and contemporary data is now available through an online mapping tool that provides situational awareness for federal, state, and tribal partners. As you may know, this tool is called WHISPERS, or Wildlife Health Information Sharing Partnership Event Reporting System, and it contains crowdsourced near real-time data and is a place to see and understand wildlife disease occurrence information. WHISPERS not only includes data generated by USGS, but also data that comes from 33 other diagnostic laboratories. What is new about WHISPERS is that the second phase of WHISPERS is nearing completion. Key of these new features are the ability for the registered users to receive email notifications for mortality events meeting criteria that they previously identified. Next slide, please. One of the wildlife diseases that you can find in the WHISPERS tools is white nose syndrome. As you know, this is an emergent disease of bat that has spread for northwestern across United States at an alarming rate. Until now, September 14, there are currently 35 states with confirmed cases of white nose syndrome and at least 12 species of North American bats that are known to be susceptible. The National Wildlife Health Center serves as a reference lab for white nose syndrome in the nation. In addition to bat die-off investigations, USGS provides technical assistance to management agencies on early detection techniques for white nose syndrome, identification of bat species, and provide insight into understanding the effects of this disease on individual bats and populations, and also conduct studies to develop management tools for the white nose syndrome. Speaking about bat identification, we're very happy to say that we know that the regular identification of bat species is typically done through morphological characteristics, which is particularly difficult for the genus Myotis. We're very happy because the U.S. National Wildlife Health Center has been working to identify novel DNA barcodes to identify the different species of Myotis, and this will be very helpful. Also, wildlife managers rely on consistent and reliable diagnostic information in order to make decisions in response to disease outbreaks. So, testing for PD, the fungus that cause white nose syndrome, has expanded very quick over the past 10 years. And the majority of the laboratories that test for PD employ the same PCR reaction, but the testing, the equipment, the reagents, and the criteria for these cause variations. So scientists at USGS have been working with the White Nose Syndrome Diagnostic Working Group and the U.S. Fish and Wildlife Service to harmonize these diagnostic methods and standards to interpret these results. Next slide, please. CWD has been, USGS has been instrumental in conducting risk assessments and developing CWD surveillance strategies for detection. Until now, according to state-based surveillance, detection of CWD in free-ranging cervix occur in 38 new counties in 11 states in the United States. USGS is leading a chronic wasting disease collaborative research initiative in Midwestern and other state agencies aimed to promote regional collaboration on deer research and management. The goal of this initiative is to align CWD efforts across various agencies to minimize redundancy, permit the pooling of resources, and allow the examination of regional scale questions. At present, the most common surveillance methods for chronic wasting disease is immunohistochemistry. So you need to wait until the animal die and you take the tissue sample and you need to take it to the lab. So now the National Wildlife Health Center is partnering with the University of Wisconsin and the Wisconsin Department of Natural Resources and USDA to develop an optimized Arctic technology for using biological as well as in environmental samples. In theory, an Arctic quick results can be developed in as long as 48 hours. The purpose of this work is to make this technology more accessible to management agencies and to open new avenues of research to help better manage this disease. Next slide, please. One before, I'm sorry. One of the most effective actions for minimizing risk of avian influenza transmission at the wildlife-livestock interface is reducing the potential for poultry to come into contact with infected wild waterfowl. However, implementing biosecurity measures to reduce this transmission is not feasible. So one of the mechanisms to address these constraints is the development of tools that allow producers to scale biosecurity activities according to the real-time distribution of migratory flocks in relation to their facility. So in collaboration with some universities and USDA, we are developing a web application to create near real-time maps of migratory waterfowl locations and provide forecast of migration of these species. This model employs machine learning and leverages near real-time information gathered by the network of National Weather Service Doppler weather radars and citizen science observations that submitted into eBird, which is a repository for wild birds observations around the world. Next slide, please. USGS wildlife disease research includes also the study the ecology of the insect vectors of disease and developing mitigation strategies for vector-borne diseases. I hear the question about the mosquito, and indeed we have a group on the Hawaii, the Big Island, working on this. We can talk a little bit later about this. Next slide. We also work with emerging disease mitigation, management, plague, and rabies. I'm going to give an example of this. So we know that sylvatic plague is caused by Yersinia pestis, and which is transmitted by fleas. So prairie dogs are susceptible to plague, and they basically have high mortality. They even get extincted when this happens. Black-footed ferrets are also high susceptible to plague, but if they even manage to avoid plague, the prairie dog populations decline and are devastating for ferret populations as they mostly rely on prairie dogs for their survivals. So scientists at the National Wildlife Health Center demonstrate that in the laboratory, some vaccines can protect black-footed ferret from plague. And since then, they start developing this vaccine in different, well, they had the vaccine, but they developed different techniques or methods to develop the vaccine. It's pretty interesting. If you see that little red kind of cookie, that's how the vaccine is being delivered in the wild. Laboratory studies have shown that voluntary consumption of this vaccine results in significant protection against plague infection. And now the work has shifted to optimize baits and the distribution methods. The ultimate goal is to license this vaccine and to target areas where black-footed ferrets are living or are released as part of the recovery program. It also can be used in national parks or urban areas where the potential for human exposure to plague-infected rodents is high. And we are also developing a white nose syndrome vaccine for little brown bats and a rabies vaccine for vampire bats. Next slide, please. And well, I would like to know from you guys what wildlife disease is most concern of your agency, and what other type of tools will be more helpful for you or for your agency in managing wildlife disease. That will be very helpful for us so we can collaborate better. Thank you.
So feel free to unmute. I saw someone in the survey added other, but I don't think they had a chance to sort of share what the other was. So that'd be great to hear.
I saw the other too.
If we don't have any direct questions, we could try to start our conversation.
Yeah.
No, please go to the, yeah, we can go to the next slide to show our contact info.
Michelle Varant has herself unmuted. Did you have a question, Michelle?
Hi, thank you. I really appreciated the overview of all the ways in which you've helped respond to wildlife diseases. And I'm with the National Park Service, and we've definitely been working closely with you and benefited from a lot of that work. So thank you. Trying to pick one of those as the highest concern is difficult. I think a lot of those are taking a lot of our time right now, as I'm sure they have yours. But one issue that I found that continues to become a more frequent problem for us that relates to water as well is harmful algal blooms.
Oh.
That I feel like there's been kind of less readily available tools for detecting harmful algal blooms and responding to those. Wondering if you could touch on any plans USGS has for developing that capacity.
So offhand, I don't know of any that are going on within USGS. I do know Army Corps of Engineers is working heavily on this. Specifically to my state, I'm out of Florida. They're thinking about Lake Okeechobee and a lot of water quality issues, including harmful algal blooms that are occurring there. That's a great question. I would love to answer further. Maybe you can write me offline and I can try to give you a fuller answer.
Yeah, I can give you a little bit of an answer.
Thank you, Ann.
Sure. This is an issue that is another issue, and I've mentioned a couple earlier, where multiple mission areas of USGS are doing work. And we've been in discussions in leadership to see if we can come together with a USGS HAB strategy. And the elements of that would be be looking at land use change and, sort of the terrestrial inputs to HABs and whether we can monitor those better. The water mission area has what they call edge of field research stations that they're piloting to look at exactly what is going into watersheds. The environmental health mission area I mentioned that just joined EMA has been looking for a long time at what makes a HAB toxic, because not all harmful algal blooms are actually toxic, and so they have differing effects on fish and wildlife and humans. And so that's their sort of niche, is to really start moving forward and figuring out what makes them toxic at what times and what are the triggers and conditions. And then, of course, the ecosystem mission area has been looking at their contributions to things like fish die-offs and our core science systems, which is the part of our organization that manages Landsat and other things, is actually looking at something that I think would be a great tool for managers, which is to use remote sensing for near real-time identification of harmful algal blooms. So with the combination of us being able to say what's happening on the land, what are the triggers for toxicity, what's happening in the water. Excuse me, that's my daughter. And then being able to remotely sense them so that we know before we have a really dangerous event. I think there's a lot going on in USGS as well.
Okay, thank you.
Thank you, Michelle.
We have John. Yeah,
yeah,
go
so
ahead.
if I can just, sorry, my name is Jonathan Sleeman. I'm the Center Director with the USGS National Wildlife Health Center. I just wanted to add on to what Anne said in that we're also doing some experimental work with different biological toxins to look at the lethal dose of these toxins in different wildlife species, particularly avian species, waterfowl. We're then looking at sort of pathological effects of these toxins on these animals and optimize what tissues or samples to take for diagnostic testing, and then looking at different diagnostic test methodologies and hopefully optimizing them. So we're trying to get better. One of the problems with the HABs is it's very hard to actually link a die-off with a harmful algal bloom. So actually trying to develop better diagnostic protocols so we can actually get more definitive answers when there are die-offs that are associated with HABs. Thanks.
Any additional questions or thoughts? Folks want to share? Again, feel free to unmute yourself and chime in or raise your hand, whatever you're most comfortable with.
We also have Maggie Hunter on the line. If there's any questions, she's a geneticist and a eDNA practitioner. You could definitely address any questions about eDNA or any other genetics kind of questions.
And then if you haven't opened the form yet, the a tool, so other questions sort of, what's your most pressing need for invasive species management? What wildlife disease is of greatest concern for your agency? What other types of tools would be more helpful for your agency in managing wildlife? So lots of questions there, so please feel free to complete that form. Okay, well, I think we can move on to the next segment. We were going to go into, I can start my video, that would be helpful, right? We were going to go into breakout sessions, but we think with the number of folks here that perhaps it would be as simple as to just have an open discussion on the topics we've covered or any other questions that you might want to ask. I think we're all here. So I encourage you to turn on your video if you're interested, but we have some time for any additional questions or things we didn't get to that you might be curious about. So maybe if speakers and folks could turn your videos back on. or something you didn't see in the conversation that you were surprised and would have liked to see? What about that?
Yeah, I'll jump in on that, Olivia. I guess, one of the things that I've noticed, and this could be wrong on my part, we work a lot with our local cooperative fish and wildlife research unit. We also work a fair amount with some of the USGS folks in the state, but I'm just kind of curious how the priorities for USGS, did those also flow into the CRUs, or are those sort of separated from the mainstream priorities of GS?
This is Ann. I can answer that, but I think John Thompson may be on the line, so he may want to.
I think he is on there.
I am on the line.
Yeah,
And,
go ahead, John. I'll add anything if I need to.
Really, Tim, they are separate. The vast majority of the CRU research portfolio is determined at the local level. And so that would be interactions with you through the coordinating committee. We do, of course, make sure that everything that we do does fit into the broader USGS mission, because that's very important as well. But
yeah,
it largely is coming from the state level. And well, I shouldn't just say state level, but the local level, state partners and federal partners.
No, I was curious as we went through a lot of, part of the reason I was curious, John, is as we're going through these, I mean, there's a lot of work that we do through our co-op unit that ties into these larger USGS priorities. Is there a way that information is sort of co-connected in GS, in USGS?
It is, as we are part of, we are part of the ecosystems mission area, and as we do keep, we put out program planning and other things, and we tie all of our efforts together, and as we report through USGS.
Okay.
I maybe didn't fully understand that question.
Well, it has me thinking about the linkages, how, maybe there's things that we can do as states to better link into the USGS priority areas, as well as working with the CRU.
Well, and one of the ways to do that is of course, we do bring things, we do a lot of work, the CRUs don't work in isolation. When you have a research need or something like that, we will work, if we don't have the expertise to do it completely, we'll work with center scientists and others within USGS. And that's quite common for us.
Yeah, in fact, a fair amount of money goes from our science centers to the CRUs to complement the work that we're doing. And so we can always do better. I mean, there are very different structures organizationally, which has always presented a challenge for how we connect better in the field. We're pretty well connected at headquarters. And as John said, when we rack up our work by what we call lines of work, the types of work we do, we include the co-op units in that, and always try to make sure that, they're in line and meeting our partners' broader needs as well. So, and I think we've got pretty good support for the CRUs, certainly here at APWA.
Yeah. Oh no, I agree. It kind of got me thinking about that of, are we not, and part of this, I'm here as a state cooperator going, have we not done a good enough job to make sure that we're helping connect these together?
Well, I think it's very forceful and impactful when the states do get together to talk about sort of what are their research needs, what are their common research needs, because a lot of what our other science centers, their non-CRU centers, do work across the biogeographical boundaries and the political boundaries and try to get common approaches to things. The CASPs are a great example of that. I know there's been some conversations in Aqua. I was in the Science and Research Committee meeting just last week about how we could do a better job of asking the states what their research needs are and seeing if we can find some commonality that we can all jointly address. So I think that'll be a really nice thing when it happens.
Yeah, I was gonna bring up the same, the AFWA task force that recently completed its work and really laid out a process for identifying those needs across state boundaries and you know, be it a regional or a national approach. I think that's going to be a very strong process for us to do that and start to look, you know, even more broad across states with similar research needs.
Well, I definitely see the need for it. We keep talking about needing to do more work on prairie streams in Nebraska and you know, the commonality we have with Kansas and South Dakota and probably the entire Great Plains there is an area that we see as a need, both from a fish, rare species standpoint, from our state wildlife action plan, potential T&E species, and then and it ties into that water issue. The water issue is at the forefront with it. So it gets complex fast, but it's actually a really important topic, I think, for us in the Midwest anyway.
Well, we'd be happy to work on that with you.
Other questions, comments on that question or others? Or overlapping work that sort of research capacity within your agency is doing where you see opportunities for engagement or intersection?
I guess I have a question. It sounded like a lot of our guests who spoke up have had some interaction with USGS at that local level. Would just put the question to the group: is that the case, or are there some of you out there that really are not making those local connections? Because that's certainly something we can remedy.
This is Cindy Leffler again. I spoke up earlier. Yes, here in Texas, I'm with the Texas Parks and Wildlife Department. We've had good interaction with the survey here in the local Texas Water Science Office, as well as through the Climate Science Adaptation Center. So yeah, I think we're fortunate in that regard.
Great.
Well, anyone else before we close out the session?
Maybe people are zoomed out by this time.
They are.
Yeah.
2 hours with no break.
Well, and the whole meeting we've all been on.
Yep. Well, with that, I'll transition to you, Anne.
Okay. I probably don't have 15 minutes of remarks, but first I want to thank all the presenters. You all did a wonderful job, and I think we got some questions out there that really require some thought. So I hope that we can continue the conversation with our partners on the line, and that you will share what you learned with your colleagues, and we can just foster more communication from here on out. We would be delighted about that. All of us on the line would be delighted to follow up with conversations about other science needs. We just touched on a few of the many, many things that USGS does. And we've been trying to do this at each AFWA meeting just to you know, to touch on what we do, but it's $1 billion organization, heavily involved in natural resources in all its forms, whether that's the biological piece that we tend to look at, but it also deals with, we've talked a lot about water, and I'll get to that in a second, but energy and minerals and, you know, remote sensing more broadly. And I think we want to be here for you and really get a good sense of what your research needs are, what your unmet needs might be, and particularly in helping us craft those sort of tools that I talked about at the beginning, those decision management tools, craft those toward your workflows and your decision making so that you get the information you need in a timely manner and that it's in a form that you can easily use, you know, not just throw our neat article we did in Science down on the desk and ask you to read it, but actually, you know, transform that data into something that you use in your decision support tools. So if I felt like we had good interest from all of the participants on each of the topics, I will say that water really jumped out at me as something that came up many times in many different formats. And I wrote a note in the chat that I hope you all saw that basically said, I think a really good next step that I can take is to have some conversations with the water mission area and see if we can get more folks, you know, in the APWA meetings and any other connections you want us to make to try to strengthen that part of the federal state interactions. Beyond that, I think I just want to thank you again for your participation and thank you to the presenters. And I'll leave it open for any more remarks or comments people want to make. And if maybe we have a little found time.
Yes, and a couple notes. We can share a PDF of the presentation with everyone after this. We have your email, and we'll share our contact information as well. And then we can share some upcoming opportunities that we have, follow-up discussions if folks want to add that to the chat or just unmute where there might be opportunities. So for example, say at the upcoming TWS meeting, also virtual meeting, right?
Yeah.
We're having a special symposium on climate change and wildlife disease. So whatever, the last week of September.
Seeing some things in the chat here. A note from Jessica Burnett that she'd be interested in hearing any thoughts on how we can have those sort of cross-agency discussions. And I do think what's going on in the Science and Research Committee is devoted to that and will be very helpful. So please join the Science and Research Committee discussions if you can. We've stolen Jonathan Maudsley, as I mentioned earlier, so I'm not sure who from ALPHA is going to be facilitating those, but they do seem to be really coming together around this idea of shared priorities.
Yeah, and I'll just note regional committee engagement. I just met with the MAFLA Climate Change Committee this past week and shared sort of where we were and sort of opportunities for them to engage with our program. And, you know, there are dozens of committees right at each region.
Yeah.
Any other upcoming events folks want to plug or other sessions before we close out? No, I applaud everyone. 2 hours on a Zoom session without a break. Applaud you for taking the time and spending it with us. And again, we'll share the PDF of the presentation. And I think I can speak for everyone. Don't hesitate to reach out and contact us if you have any questions. No? Anything else, anyone? Okay. Well, thank you all. Hope you have a good, safe rest of your day and week.
Thank you. Really appreciate your coming.
Wow.
Mon, are you still there?
I can see her, but she's not answering, so I'm not sure.
So I
Sorry,
think
I was muted.
Oh,
Sorry.
no problem. So do I know, sorry, if I stop recording, right?
Yes.
Stop cloud recording.